In this short video, what I want to do is introduce an idea that I didn't realize that I skipped. It's inadvertently skipped in the chapter 2 material. But what I want to do is I want to talk about the idea of a matrix transpose. So a matrix transpose. So given a matrix A, and let's just do this with an example to start with. But let's say I have the matrix 1, 2, 3, 4, 5, 6, 7, 8. This is a 2 by 4 matrix. A transpose is going to be written as AT, and that's going to be a 4 by 2 matrix. And basically what you do is you look at A, and your rows of A become the columns of A transpose, and vice versa. Your columns of A become the rows of A transpose. And so A transpose is going to be the 4 by 2 matrix. It's going to be 1, 5, 2, 6, 3, 7, 4, 8. Okay, and that's all the transpose is. So in general, if A is an m by n matrix, then A transpose is an n by m matrix. And that's really all there is to say, except I guess I should add 2 more pieces of information here. Note that, maybe 3 things that I want to say. Note that if I take the transpose of the transpose, this just lands us back at A. I want to note that, and so that first thing that I just said there, the transpose of the transpose being the original matrix A, should be a fairly obvious thing. I don't really feel the need to justify that. If I take the product of the transpose of 2 matrices, it turns out what we get is the transpose of the products, but the product is in the reverse order. And notice that it can't be in the same order because it's possible if A and B have different sizes, then switching the order of multiplication can change whether or not the product is well-defined. So you have to switch the order in order for the product to be well-defined, and there's some other good reasons why the transpose works like this. So if A, for example, just was a 2 by 5 matrix and B was a 5 by 3 matrix, then B transpose will be a 3 by 5 matrix, A transpose will be a 5 by 2 matrix, and the products are well-defined because you need the number of columns of the first matrix and the number of rows of the second to be equal in order for the product to be defined. So that's how the transpose of a product will work. The final thing I want to point out is just, I want to note that if I take the transpose of an inverse, that's the same as the inverse of the transpose. Again, that's not completely obvious, but I'll leave that to you to check just for some matrices A.